Hey everyone, we're going to start by talking about the real number system. This is to fill in your notes or to keep you from getting behind if you're not in class. So we're going to start with the word terminating. Terminating means to come to an end. That means something is stopping. When you come to the end of a sentence, you put a period in. So that means that that sentence has terminated. It has ended. When you terminate on Friday, your school week has terminated because it's coming to an end. Okay. Now let's talk about repeating. Repeating means a pattern that happens more than once. Oops, I misspelled than. All right. So when a pattern repeats, it means that it is happening over and over and that it is exactly the same. For example, red, blue, green, red, blue, green, red, blue, green. That's a pattern that happens more than once. And that means it is repeating. All right. So we're going to talk about the real number system, and it has two main categories. So real numbers are at the top, then you have two main categories of real numbers. The first is rational numbers. All right. So rational numbers are fractions, all fractions. I'm going to go ahead and put all there, where both numbers are integers, and I'll be telling you exactly what integers are in just a bit. Okay, so rational numbers are all fractions where both numbers are integers. All right, the other thing you need to know about this is that they are terminating and they are repeating decimals. Okay, so all fractions where numbers are integers, if you put them in a calculator, they are either going to terminate or they are going to repeat. All right, now let's come over here and talk a bit about irrational numbers. So irrational numbers, if I can get my text box here, irrational numbers is the set of all non-terminating, that means they do not stop, okay, and also non-repeating decimals. Okay, so irrational numbers are a set of numbers where the decimals never terminate, they keep going forever, they never form a pattern, and they never repeat. Okay, so we're going to start there, and then we're going to go on and give you some more specific examples. For example, let's look at the square root of 225. That is equal to 15. That is a beautiful number with absolutely no kind of decimal doing anything. So that is definitely rational. All right. And because it can be written as a fraction, let me go ahead and just type this here, and I'll move it up in a minute when I can. There you go. Because it can be written, okay, and I'm going to come back down here, or represented as a fraction. For example, this fraction for 15 would be 15 divided by 1, okay, because any number that's just standing there by itself, you can divide it by 1 and it will still be the same. Okay, so again, the square root of 225 is definitely rational because it can be written as a fraction. Okay, let's go on to our next example. Pi. You can also just type the letters pi and that will give you pi. Now, it is definitely irrational. All right. And the reason it is irrational, I'm just going to come down here and type it and say it is a non-terminating, non-repeating decimal. All right. So what that means is when you put pi into your calculator, if you notice 3.141592654, it stops there only because your calculator runs out of room to keep printing digits of pi. But we know that pi goes on forever and ever and ever, and it never stops, never repeats. That is why it's irrational. Really quickly, I want to show you two different types of square roots. This square root gave you a beautiful number, okay, an integer. We'll get to that later. But, or actually, this is also a natural number and a whole number, but like I said, we'll get to that later. But there are two types of square roots, okay? You can have a square root that gives you a beautiful number, or you can have a square root that gives you a mess like this. So this square root here, the square root of 225, is definitely rational, but the square root of 7 is irrational because it never stops and never repeats. When you put a square root into your calculator, it will be obvious. If it looks like 15 or negative 15, it is rational. But if it looks like anything else with decimals, it is definitely going to be irrational. Okay? So let me go down to this fraction, 17 divided by 3. That gives me 5.66666666, and then it goes to 7. That is not really a 7. What happened here is the calculator ran out of room, so it rounded this 6 up to a 7. Okay, so just ignore that last number, ignore the 7, and just see that the 6's are repeating and they are never going to stop. So a fraction, just like we said before, is definitely rational, and we will describe it like we did above and say that it written as a fraction and it is also a repeating decimal. All right, let's go on to the next page. So as we talk here, we'll see that we have real numbers, okay, here. And I'm going to go ahead and continue trying to make this work with the text boxes so I can put that in. So up here at the top, I'm going to say every number that you will see during this class, we promise, is going to be a real number. As a matter of fact, every number that you've worked with up to this point in school is a real number. Rational numbers, like we said, are fractions where both numbers are integers and they are terminating and repeating decimals. Irrational numbers is the set of all non-terminating and non-repeating decimals. Okay, that's going to be pi and any messy square root. That's how I like to describe it. So it will be pi and the messy square roots. Okay? Now, down here, we're going to start talking about integers. Okay? Every whole number and their opposite is an integer. And I'm going to show you this. I'm going to see if it'll let me switch to my pen here. Hold on. And that way, or even a highlighter might be better. Let's see if it lets us do that. Yeah, that's going to work. So all integers are, it's going to be the whole number and its opposite, whole number 4 and its opposite, -4, whole number 3, 2, 1, opposite numbers, -3, -2, -1, and of course whole numbers include 0. So that's how that works there. Okay? So sometimes looking at these number lines on your notes makes it so much easier to tell what kind of number it is. So let's go on to our next page and see what we have there. Next, we have whole numbers and natural numbers. So I'm going to come back here, and first I'm going to use my text boxes to fill in words, and then I'm going to come back and get my highlighter, okay? So whole numbers are every natural number and 0, all right? Natural numbers are numbers that we use to count, and they do not include 0. And I'm going to go ahead and put that in here. Do not, and I'm going to put that in capital letters, include 0. Okay? All right, so I'm going to come back over here and get my highlighter and make sure it's the right space. So every natural number and 0. So let's start at 0. 1, 2, 3, 4, 5, and you keep going to infinity. 6, 7, 1,000, 1,000,000, and so on and so forth. Now, natural numbers down here are used to count. Well, I like to count tacos, but 0 tacos will not work for me. So it definitely starts at 1, 2, 3, 4, 5, and so on. It just keeps going on and on and on. Anything you can count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on to infinity. So the difference between natural numbers and whole numbers is that 0. Whole numbers includes the 0. Now let's look here, and I'm going to go ahead and try to go back to my stylus and see if we can figure out some things just by looking at them. First of all, -15 is an integer, correct? And it would be over 1. So it wants us to label, and then it wants us to put these numbers where they belong. So maybe I should just go ahead and label first and see what I can do there. So down here, these are our natural numbers. They are the first numbers we learn when we are young. We are brand new in learning how to count our fingers. So those are natural numbers. Above that is whole. Above that are our integers. And above that is rational numbers. Over here in this oval that sets up and down, these are all the irrational numbers. All right, so now that I've done that, I'm going to come up here just for fun and see if these drag and drop. Oh, they do. Thank you, Amber Benson, for being wonderful. So this -15 is definitely a real number, definitely rational, and it is definitely an integer. Okay? The square root of 2, let's go ahead and put that in our calculator just for fun. Look at that. What did I tell you about square roots? They are either beautifully neat and go over here, or they're beautifully messy and they are definitely irrational. This is a number 6. Let's look. Let's see what number 6 is. Well, it's definitely real. It's definitely rational, but let's keep going. It is also an integer. It is also whole, but it is definitely natural. Remember, we're putting these numbers in the most specific subset. Up here is the broadest thing, real numbers. Then we get more specific, rational, integers, whole, and natural. Over on this side, irrational is the most specific. Okay, for rational, it has 3 more levels of of getting more specific. Let's just say it that way because I can't say the word. All right, 17 divided by 3 is a decimal that repeats. It's also a fraction, so we know for a fact that this is rational. Okay? 0, the most specific case for 0 is always whole. All right? Pi, we know that pi is an irrational number. As a matter of fact, I often call it the royalty of irrational numbers because it always goes with irrational. 62%. Let's come over here and figure out how we're going to turn 62% into a decimal. Well, we're going to divide it by 100, which gives me a decimal that stops, 0.62. Well, my decimals that stop are definitely rational, so we're going to put it right there. Now we have 5.65 with a repeating bar. Let me show you what that looks like if you write it down. It's 5.65, 65, 65, 65, 65, and it keeps going forever. I am going to run out of room on my calculator screen, but I just wanted to show you that it's just that line above the 6 and the 5 means it's repeating forever. So that means it's definitely a rational number. All right. Negative 3.4 is a decimal that stops. Again, that means it is a rational number, so we'll put it right over here on this side. And then finally, we have a number 2.34344. It is repeating, but it is not repeating in a neat pattern. This is a progressive pattern. It only comes over here if it repeats in a neat pattern. So this is definitely irrational because it's going to keep going forever. All right? And that's the real number system.